next. So let's go through all the examples for A. So this is about linear equations, so straight lines. There's a lot of examples here, but you've done all of this last year, so if you need to, make sure you go back and revise, and you should be fine. Alright, so let's start with 4.1. Find the gradient of the line connecting 3, 2, and 5, negative 4. Alright, so this is just using the gradient formula. M equals y2 take y1 over x2 take x1, which equals, pick your points for y2, y1, x2, x1. So negative 4 take 2, and then 5 take 3. Alright, I'm just going to let the first coordinate be x1, y1, and my second coordinate x2, y2. You can swap them around the other way, you'd still get the same answer, so it doesn't matter which way. As long as x1 goes with y1 and x2 goes with y2. So we have negative 6 over 2, gradient is negative 3. Done. Okay, let's do 4.2. And if you need to find a specific example, just skip ahead in the video. Find the x and y intercepts of the line 2x plus 3y take 6 equals 0. Okay, so the x-intercepts occur when y equals 0. So 2x take 6 equals 0 if we let y equal 0. 2x equals 6, x equals 3. The x-intercept is 3, 0. And the y-intercept, let x equal 0. So we'll get 3y minus 6 equals 0. Solve for y. Y equals 2. So that means the y-intercept has a coordinate of 0, 2. Okay. Nice and easy. 4.3. Find the equation of the line with gradient of 4 and y-intercept of negative 3 in the form ax plus by plus d. Alright, so we've been given the gradient, and we've been given the y-intercept. So let's just write this equation, the equation of this line out using gradient intercept form. So remember, y equals mx plus c. So y equals 4x minus 3. And then we just need to rearrange it to make the left-hand side equal 0. So let's go negative 4x plus y plus 3 equals 0, because it wants us to put the x term first, followed by the y term, followed by our constant. So that's 4.3 done. Alright, 4.4. Find the equation of the line 3x plus 4y plus 6 equals 0 in the form y equals mx plus c. So this is just a little bit of rearranging. So keep the y on the left-hand side and take away 3x from both sides, take away 6 from both sides, and then divide both sides by 4. So that will give us negative 3/4 x. Take 6 over 4 is the same as 3 on 2. Okay, so the gradient is negative 3 over 4, and the y-intercept is negative 3 over 2. Done. Moving on, 4.5. Find the equation of the line with gradient 2 through the point 3, 5. Alright, so we want the equation of the line. We've been given gradient, m, and a point. This is when we can use the gradient point form of a straight line and sub in these values. So gradient point form is y take y1 equals m bracket x take x1. Alright, sub in all our values, so y minus 5 equals 2 outside x take 3. And we're not told what form to put this equation in, so maybe I just do an extra step of arranging it into y equals mx plus c form. Alright, so expand my brackets, add 5 to both sides, so I'll get y equals 2x minus 1. Done. Okay, let's have a look at 4.6. Find the equation of the line connecting negative 1, 1, and 3, negative 7. Okay, so this is where we can do this. We actually can do this in one go, but first I'll just label my points. I'm going to do it this way. Because we need to find the gradient as well, because all we have here are 2 points that this line passes through. Okay, so, sorry, that should be y1. So x1, y1, x2, y2. Now, I'm going to use gradient point form. So y minus y1 equals m x take x1. And then I'm going to sub all this in. So y minus 1 equals, now we're going to use the equation for the gradient. So instead of, because we don't know m right now, we need to calculate it, but we know that the gradient is y2 take y1 over x2 take x1, so we're going to sub that in right here. So this just gets a little bit, could get a little bit messy, but you can, this is how you do this in one go. So 3 take negative 1 is going to be 3 plus 1 outside of x take x1. X take negative 1 is x plus 1. So there we go. And then let's just simplify things. So y take 1 equals, this is negative 8 over 4, so that's negative 2 outside of x plus 1. And again, we haven't been told which form to give our answer in, so it doesn't really matter, but I like to work with y equals mx plus c, so I'm just going to do that. Alright, so expand my brackets, add 1 to both sides, get y by itself on the left side. So we have y equals negative 2x take 1. Okay. Alright, a few more to go. Let's do 4.7. Find the equation of the line parallel to 2x plus y plus 6 equals 0 through the point 2 and 5. Okay, so we want to find a line parallel to this line, 2x plus y plus 6, but it also has to pass through this point. Now, what we know about parallel lines is that they have the same gradient. So let's find the gradient of this line, which means we need to rearrange this into y equals mx plus c form. Alright, so we can see that the gradient is negative 2. Alright, so we now need to find the equation of a line with a gradient of negative 2 that passes through this point. So we've been given a point, so that means we have x1, y1. So this is, again, gradient point form. Very common. So y minus y1 equals m. X take x1. So y minus 5 equals negative 2. X take 2. Alright, and then same as before, same process. So y equals negative 2x plus 9. Okay, let's have a look at 4.8 now. Find the equation of the line perpendicular to y equals 5x plus 2 through the point 1,6. Give your answer in the form ax plus by plus c equals 0, where a, b, c are integers. Okay, so we're just trying to find a line that's perpendicular to y equals 5x plus 2. It has to pass through 1,6, and we need to rearrange it after we find it. So if we have a line y equals 5x plus 2, any line that is perpendicular to that, so meeting at right angles, is going to have a gradient of negative 1 over 5. Okay, remember your perpendicular lines, it's the negative reciprocal of your gradient. So if your gradient here is 5, your negative reciprocal is negative 1/5. Okay, and then since we know our point, we're just going to sub this into our point gradient form. So y minus y1 equals m x take x1. Alright, so since at the end of the day we want all our coefficients to be integers, I'm just going to multiply both sides by 5 here. I'll save us doing it later. Okay, so that's multiplying both sides by 5. Expand both brackets. So 5y take 30 equals negative x plus 1. And then we want to rearrange this equation and make the right side equal 0. So x plus 5y take 31 equals 0. And we are done. Alright, lucky last, 4.9. Let's have a go. Find the point of intersection of y equals 3x plus 2 and y equals x plus 4. Okay, so we're trying to find the point of intersection, which means we're going to let y equal y. Alright, so basically sub one equation into the other. Then we can solve for x, so 2x equals 2. That means x equals 1. So at x equals 1, that's where the point of intersection is. Now we just need to find the y-coordinate. So when x equals 1, y equals, I'm just going to sub 1 into x plus 4, because that's nice and easy. So y equals 5, so that means point of intersection is 1, 5. And we're finished. Okay, so that's all the examples to help you do exercise 4A. So now you can go ahead and try those, see how you go. Have a good one, and I'll see you soon.